Okay guys, so now I want to take a look at numbers 1 and 2 in section 3.2, kind of looking a little bit deeper now into what's going on with these scatter plots. So what we have is they gave us a kind of height and weight table for some students, and what they ask us is, does there seem to be a relationship between height and weight? And to me, it looks like there is, and it kind of makes sense. Like, the shorter you are, the less you weigh, and the taller you are, the more you weigh. I mean, you're taller, there's just more of you, so you're going to weigh more. And it kind of makes sense if you look at our data. The shortest person is 61 inches tall, and they weigh the least, 95 pounds. The tallest person is 69 inches tall, and they weigh the most, 140. So just looking at the shortest and tallest person, it kind of makes sense that there would be a relationship. But so what do we do? How do we do this? Well, we have here this kind of data. If you look at the title of section 3.1, this is called bivariate data. So bivariate. You can kind of see the word variable in there, variate. And bivariate, bi means two. So there's two variables. Every row of this table here is a person. And so this person, we measured two things about them. We measured their height, we measured their weight. That's why it's bivariate. We measured two variables for each row, for each person. So what do we do? How can we kind of look at this? Well, the scatter plots that we saw from the last section, the way they did that was the height was like the x value, and the weight was like the y value. And so now each person becomes a point, and we can use kind of it's like an XY grid right here to kind of graph this ourselves. So I'm going to label this one here 61, 62, 63, 64, 65, 66, 67, 68, and 69. And then going up here, I'll go 90, 100, 110, 120, 130, and 140. And so all we're going to do is we're going to plot all these points. So the first one was 65, 105. So we're going to go over 65 and then up to 105, which should be right about there. Oops, sorry, right about there. And then we're going to do 65, 125, which that would be right about here. Disregard this point, guys. Sorry about that. 62, 110, that's right here. 67, 120, that's up here. 69, 140, it's way in the corner up here. 65 and 135, that's right here. A lot of people are 65 inches tall, looks like. 61 and 95 is right there. And 67 and 130 is right about there. So we can kind of see, it looks like all the dots are kind of going in a certain direction, similar to like the sugar was going in a certain direction. This one's, it looks like if we had to like draw a line through this, it wouldn't be that difficult. We've somewhere right about in here somewhere, give or take, somewhere like right about there. And that kind of works out. Now, what they ask us to do now is they say, okay, well, if we were going to add a point to this scatter plot, what would be like a reasonable place to put one? And this one that I put in the wrong place looks like a pretty good place to put one, actually, kind of right in the middle of everything. But then we can also think, what would be kind of an unreasonable place to put one? If I put a dot, if I want to add a dot, let's say here, we'll put one right here. I mean, would that make sense to add one way up here? Probably not, because it doesn't really fit the data. It doesn't really fit in with everything else. So putting one up there would not really be reasonable. I would want to put it kind of more in line with what's happening right here. If I drew a line, say, through all this, probably staying pretty close to that line. That's what a reasonable place to put something would be. Okay, so I just want to show us kind of what's going on there, how to plot the points, and then kind of how to decide if something is reasonable or not reasonable.